Hello and welcome to this fabulous episode of the AI Show. How's everybody doing? Another fabulous Monday. It's summertime here in North America. So I guess in Australia you're kind of entering the winter time. That's cool too. All right, we've got an awesome show for you today. We have guests. Well, Jennifer is amazing. We'll talk to her at top of the hour. But first, where is everybody coming from? If you can put it into the chat, we'll give you a little shout out. Where you're coming from, what's going on, how's life treating you, that kind of thing. And I'll tell you what we're doing today. They moved things around a little bit on my thing, so let's see if I can figure it. Let's see if I can figure it out. Entire screen. There you go. Hello, everybody. Today, on the wonderful AI show. Ooh, looks like we got some people here. Keep telling us where it's coming from. I'll put it. There's like they moved it, so now it's hard for me to push buttons. What is this? Why? Like you see how everything's all moved around? It's moved around, so I have to go side of the eye now. Side of the eye. Hello, David. How are you, my good friend? Hello, Rob. Good morning from Seattle. Another Seattleite. Hello, David. Minneapolis. A for wall. A4 wall. I love it. I kind of want to know what that means. New York City. Hello. Willkommen. I don't know why I said it in German. I'm a weirdo. Okay. Number one. We're going to continue our app, Neuer.ai. It's a new startup. Slash. Oh, it's Laura! I did not know that was you the whole time. Laura. Hi. Thank you. Neuer.ai, which is our marketing. Hold on. Taglines are important. Our AI marketing specialist. AI marketing specialist. Hello from Brazil, by the way. Switzerland. I feel like if I leave this on, it's gonna not be as cool. Our AI marketing specialist with LLMs and Prompty. And then number two, Jennifer Marsman is going to come on and do something with Wordle, if I remember correct, and some LLM stuff too. Together, it will make the synergy of a lifetime. Look at this. I do not draw these sparkle lines with, it's not very often I draw sparkle lines. So, sparkle lines and all. We have someone from Piedmont, New Jersey, North. I almost said New Jersey. Like I would need a severe slap. Definitely not New Jersey. North Carolina. Side of the eye here. Because they moved my stuff, so I gotta look side of the eye. Italia. I was in Italy a couple of weeks ago. Milano. What a delightful place. Delightful. So yeah, that's where I was. Put this over here. And Avi, the amazing Cassie Breviu, who one of the other hosts of the show, who is fantastic, amazing. We should do more like talk show style, like look at the AI news and like either laugh because it's fake, because a lot of the AI news is fake, or be like, ooh, we just learned a thing. Fake or not fake. We should have a segment. Like, we should have a fake or not fake segment. Hello and welcome to this section of the AI show. Fake or not fake with Cassie Breviu and Seth Juarez. Article number 1. AI is going to destroy us all and eat our brains. That would be the entire show. I mean, seriously, I don't know what else we would do. Feels like that would be the entire show. Okay. Alrighty. Fake or not fake? Rob's all. Wait, are you trying to tell me that you can't trust everything you read on the internet? Look, I read on the internet that 90% of the stuff you read on the internet is fake. And obviously that was penned by Abraham Lincoln, is what the article said. Abraham Lincoln literally said, 90% of the stuff you read on the internet is not real. One of our amazing five fathers, Abraham Lincoln. You can take that quote to the bank. I don't know what you would do with it there, but okay. Wow, this is some intense music. Intensity. All right. Here is our application. Here, we'll control plus this. We'll control plus this because I feel like it's. And then at the top of the hour, Jennifer Marsman's going to come on. By the way, I've known Jennifer for I think umpteen thousand years, and we're still both a spry young age of 27. That's what we tell ourselves. All right. I don't even remember what we're doing here. So we got the Vem is going. Okay. So my sense is that there's a Flask app. Flask debug. There is no Flask. What did I do? Oh, that's right. We're using Fast API. We're using Fast API, and we create an article called Yo Mama. Boom. I must have ended the show on a high note last time. By the way, as we do more shows, I think I might stick with building stuff and have occasional guests just moving forward. Because I don't know, I like building stuff. And Rob, as he said, Captain Jean-Luc Picard said, posted on MySpace, use the Force, Harry. I remember seeing that the first time. It was a powerful quote by Jean-Luc Picard. I saw it on MySpace. I follow Tom, obviously, and it was a spiritual moment for me when he said that to Harry. Thank you, Rob, for grounding us on what actually is important. Okay. Let's see. How do we run Fast API? I don't even know. We switched to Fast API, and we just Fast API because this is our LLM backend, Abby. Fast API, and the thing that comes to the top is Tricentis. This is not what we wanted. Maybe if we scroll. Oh, here we go. Fast API. Features. No, learn. Learn. Oh my gosh. Just this. Okay, we did this. Fast API. Oh, there we go. Fast API dev main. Thank you, sir. Thank you. Now we know. I probably need to CD into the API. CD API. Fast API dev main. Here we go. The server is started. Oh, I wonder what these docs look like. Ah, this is nice. Cassie, this is way better than where's my phone? Oh, there it is. This is way better than Flask. Pamela was right. She was right. Of course she was. This is delightful. Okay, and then the other thing was now we're gonna go to the. We need to wire up the. Vite avec vitesse, s'il vous plaît. I don't know why I half Italianed it. I feel like I need to apologize to you, Umar. Hopefully I said it right. I Frenched it a little bit in Italian. So, and this one's just npm run dev because I am lazy and that's what I do. Here we go. So example, start work. Yo mama. Okay, so this is working. So what I want to do now is let's change this up a little bit because I think what I'm going to be doing, and maybe I put something in lay readme. Paragraph keywords, target audience, social media posts. How about them apples? We kind of wrote this for ourselves. We're going to be super successful now. And by the way, the more AI stuff I build, the more I realize that the hardest part of all of this is React. React. Every time I say React, I feel like I need to be like, okay, app. Looks like we have our toolbar. Go to def. Oh, wow. I'm like using, dang. I think I'm like using like Redux and everything. Holy cow. This is amazing. Yeah, I am using Redux. Why do I even need this? Where is this used? Go to references. I'm not using it anywhere. I can kill it. Start writing task async. And then this is the configuration. This is the endpoint. I think the endpoint we're getting from here, localhost 8000. Okay, cool. And so we want three things. We're going to go to the toolbar. This is each tool, I think. And this is the toolbar. Okay. So I don't think we need this. Or maybe we do. Before we start breaking everything, let's figure this out. So this is a document icon. This is a debug icon. Looks like this is the task thing. So let me, how did I, this is clever. I made a tool and then I pass in the icon for it. And then, so I can, so this toolbar down here, I can add as many tools as I want. Like, let me see. I bet if I do this again, it's going to, yep, see? It shifts between articles so that we can have multiple things. Okay, cool. Okay, cool. Okay. So we don't need all of that stuff. So let me go over here. Bonjour, Mathieu. Rapidement, s'il vous plaît. Avec vitesse. Parce que le chose que je veux faire, je le faire avec quelque chose qui s'appelle vite. Vite. Everyone says vite, but it's vite. It means fast in French. That's for you, Mathieu. By the way, France is amazing. I need to come back every day. Every day. I don't want this one. Every day. Okay. So let's go to the task here and let's change this up. Go to definition. Looks like we have a couple of things here. So let's make this into a component so that we can type stuff in here. We'll call it a new file. New file. And this is going to be Enrique de Madrid. Qué placentero, la verdad. S'il vous plaît. By the way, I used to live in Spain, in Málaga and Sevilla. Entonces hablo español como si fuese de España mismo. Yes. Okay. So we have this thing. I feel like there's a better way to do this. You know? Because it's the same thing. Like, this is the same thing. So we'll make this into a component. A new file. And what do we want to make this into? Can't be param. Can't be input. We'll call it source. Source.tsx. By the way, if you're sitting here wondering, like, when are we going to get to AI? This is it. I mean, we'll get to the AI soon, but I got to have a way to, like, post something. You know what? No. We'll leave this here for now, but let's get to the AI part, because I think with the AI, we want to have an agent, new folder, and we'll do this agents. And what we want to do is, let's see the README, because I want to do that last, because I want to get to the AI. Input paragraph keywords target audience. Okay. And so for me, that means that we're going to get a um, paragraph. Cool. Perfect. So let's do that. And then we're going to do a new folder. And this one's going to be our copy. Right. We'll call it writer agent. And the way that we do stuff in Prompty is you just write a new Prompty file, right? Let's see if I already have. Yeah, I already have configuration here. And what this is in Prompty land is if once you install the extension, you can actually point. I think we're making this better too, so that it shows up a little bit. But this points to different endpoints, so that when I'm working with these things, it'll just fill this in. So, for example, my deployment's going to be GPT-3.5 Turbo, and this we don't need because this is coming from the settings, right? And so if I hit play, what's going to happen is this file is going to be run, and you're going to see that it actually hit the LLM, right? And so what this is Prompty is an asset that allows us to quick test things, right? So here's the good bit. The good bit is, first of all, let me change this. Rename writer.prompty. Cool. And remember that in the README, we'll split right. We have a paragraph that's a string. The input's a paragraph of we'll call it the description. So this is now going to be a description input. Keywords, the words that we must, the keywords that you want to focus on. Keywords, right? And for this, there you go. And then the last one is the audience. So basically what I've done is with Prompty, we are describing the prompt that we're doing. So this is going to be a AI marketing copy assistant. And then this one here. There we go. And I'm literally stealing from AI right now. There you go. And notice, by the way, that the Prompty file, which is really cool, has we have some tooling that tells you when things are wrong, etc. I think it even has, let's see if the completions are working. Yeah, see, it even has completions of all the stuff you can put in there. It's actually quite nice because, again, if you think about it, all we're doing when we're working with an LLM is we're making some text, we're sending it to an LLM, and then it's producing text, right? And so Prompty represents how we assemble this thing, and then it returns stuff, right? So that's what's going on here. Okay. So we have a description, keywords, and audience. And now what we need to do is let's clear this out. We need to fix this so that it does the right thing. You are an AI assistant who helps. You are an expert AI marketing copywriter who helps people write engaging social media posts. When given a description description of an event, you can generate a post that will help attract and I'll provide tips on how to make the event more successful. Nah, I don't want that. By the way, are you noticing how AI is helping me not have to think so much? It's great. This is great. Okay, help attract attendees. You will also be given some keywords to include in your posts. You will also be given some context as to the audience you are writing for. Make sure that I wanted to finish the sentence. Make sure that you personalize. Nice. Okay. This is kind of cool. All right. Audience. Okay. And by the way, as you're going, I know. Yeah, man. You are AI helping you build AI. Yes, it is. Hello, Ivana. Some of my favorite people. I have not made it down to where y'all live in a long time, so we need to sort that out. Make sure you use the following description. Nice. Descripciones. And by the way, as you're going, we have this handy Prompty thing where you can hit this. Hold on, let me just make sure. Yeah, you see that? Like this is. It says Seth, right? But it's like the next AI show will be about using Phi 3 Mini in your browser. And by the way, the Prompty thing, you can use. It's just regular. It's regular YAML, so you can do stuff like this, right? Nice. Keywords. Gen AI. LLMs. AI show. Not first name. Phi 3 Mini. Okay, cool. Audience. Technical audience. Technical audience that wants to build with LLMs. With AI. Cool. And then we'll. Okay, now this is pretty cool. I hope you're seeing like that. This is like actual prompt engineering now, which is super cool. Description. Use the following. The following keywords should be included in your response. And right now, this is right now it's trying to do handlebars, but it's Jinja 2. So Jinja 2 loop. No, I don't want this. I want the docs. Oakley dokley. Gotta sit up. Oops. I lost my audio. Here we go. It looks like we got this little handy dandy. Oh yeah, thanks, Jennifer. When I said I lost my audio, my earpiece fell out of my thing, so I stopped hearing things. maybe that's good, to stop hearing things. And now we've got this, and we're just gonna, and then we're gonna say, it says user, but keywords. I think it's keywords. Is it? Yep. Keyword, and then we're just gonna be like keyword. You see that, by the way? How it's happening? So we got the keywords. So we'll do this description, task description, task. Oh, we'll say event description. The event, because this is for the AI show marketing. Okay, and then the last thing is audience. No, why do you keep doing that? Keep the following up. Look at that. Hey, yo. Boop, boop. And you can see, like, over here to the right, you can actually see this thing getting built. You see what I'm saying? Cool. Cool. Response. Make sure the response is engaging. And I'll try to the responses should also be appropriate and respectful to the audience. Return a list of posts along with any emojis or hashtags you think would be appropriate to include in the post. And then here, can you create a list of creative posts, social media posts? Boop. Okay, so I think we did it. We AI'd the thing. So let's see if it works. So we have this thing. Here's us trying it out. We're using GPT-3.5 Turbo. I guess we can close this because it looks good. And what's going to happen is this is going to be put together. Here we go. Look at this. Calling all AI enthusiasts. Blah, 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 get ready to explore. Blah, 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 blah. Nice. Curious about the latest breakthrough. These are great. Ah! 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 And we'll leave it at that. So we'll Control-C this because it's top of the hour. And we want to make sure to get our friend Jennifer on there. So let's do this. Control-C, yes. We'll delete this source thing for now. Delete because there's nothing in there. Then Control-C here. Yes. Shutting down cd dot get status. Get add dot get commit -m. Added our social media agent. By the way, how cool is that? Because now we just need to add some code, and we'll do that next week. Okay. So we're going to put that in there. And then we'll get push origin main github.com Seth Juarez, and then lawyer is the one. And so now when you go into the API, you're going to see the writer, Prompty. It's literally this thing, which is super cool. And with that, how do I close this? Oh my gosh. I don't know how to stop sharing my screen anymore. Stop screen sharing. I guess I do. All righty, let me get Jennifer. How you doing, my friend? Are you there? I just Jennifer.
Hi. Can you hear me? Can you see me? Hey, Seth.
I can't. How are you?
Good. How are you?
Fantastic. Now, I've known Jennifer for
Oh,
what? Like
a
15 years?
long time, my friend, a long time. So back in the day, back before machine learning was cool and like everybody was doing it, it was like me, Seth, and Gary Short. We're like doing
That's
all
right.
of the
There's
machine
3
learning
of
talk.
us.
It was like the three of us on the speaking circuit all the time, and we would always run into each other. So yeah, Seth and I think I met you at one of the Tennessee conferences. I forget which one.
Code stock.
Code Stock, that was it. Okay.
I
Yep,
think it was
you did a
2008.
workshop. Yeah, it was a long time ago. It was a long time ago.
And when we
I
say the only 3,
know.
we mean in the .NET space because we were obviously there's people doing machine learning before, but in the .NET space,
Mhm.
it wasn't something that people were thinking about yet. And to be honest, it really
Yeah.
hadn't reached the zeitgeist. So, what are you talking about today? And maybe I'll turn it over to you.
Oh my gosh. Well, what I want to tell you about today is it's like, all right. So, one of the fun things that I get to do at work at Microsoft is I get to create demos for the CTO. I am Microsoft CTO Kevin Scott's demo engineer. So that's one of the things that I get to do that's super fun. But when you do like cool demos, like a lot of times it's just like the final product, yay, look, it works. But you don't get to see like all of the thinking that went into it. So what I want to do today is actually share with you guys the whole mindset I went through when I was trying to do a demo to solve Wordle. Um Okay, so this is going to take you through like the very beginning of like what was my very first prompt, what did I try, and then we're going to walk all the way through and see if it can be done. All
All right.
right, so that's
I'll
the
leave
plan
you to
for
it.
today.
I'll leave
All
you to
right,
it, my friend.
cool. Cool. All right, so let me start by like what is Wordle, just in case folks don't know. So Wordle was actually this source of joy during COVID. Do you play Wordle, Seth? I don't know if he does, but for those of you who don't play Wordle, what it is you guess a new 5-letter word every single. There's a new puzzle every single day, and it's a 5-letter word. So you just guess random letters, and then each time you make a guess, it has to be a real word. So if I knew that there was like a K, an L, and a W in it, then I would have to guess a real word that contained those 3 letters. You can't just put like a random string of letters in there. It has to form an actual word. And there's a new one every day. It has to be a thing. And you have 6 tries to get it right. Okay. And then the last thing to keep in mind is that the color is really, really important in solving this. So after you submit a word and hit enter, the letters will all turn colors. And if it turns green, that means that that letter is in the word and it's in the right position in the word. And then yellow means that letter is in the word, but it's in the wrong spot. And then this light gray means that it is not in the word at all. Okay. So that's the very simple version of it.
Yeah, I never
So
got into it.
you didn't? Oh, I
I was
love Wordle. It was,
everyone like they would post it on social media. I'm like, what is
yeah.
this?
Yeah, no, it is so much. It was like my source of joy during COVID, like when everything else was kind of falling apart. You
Yeah.
had your cup of coffee in the morning and your 5 minutes to do the Wordle, and you were like, this is fine. The whole like fire in the background meme was like just totally Wordle was my this is fine.
Would I
So
be
I,
able to
I love
start it?
this. I love
Would I
this.
be
I
able to
love
start it now and be cool, or is it like
Yes. I
that?
mean, be cool. I don't know because I guess it's probably it was like really cool during COVID, not because you're not cool, because you
Oh god,
obviously
okay,
are.
yeah. Oh, I got you.
Obviously you're cool, but
Sure.
like just it's probably peaked at this point, but I don't know. I still love it. I still play every single day
Okay.
because I am a dork.
Okay.
But let's talk about why I thought this was such a cool problem for machine learning. Why I thought this was cool is it actually, when you think about what you need from that image. So if we start to think about image understanding, right? What you need to pull out and extract from that image is 3 distinct things. You need kind of the OCR type knowledge to understand like what characters are on the screen. You need positional information. That's super important because you have to know like, was it in the 3rd spot or the 2nd spot, so that you know like where it belongs. And then you also need to know the actual colors that it turns, because the color gives you that information about whether it's in the word or not and whether it's in the right spot or not. So all of that is super important. And that's and position, especially like as you guys probably know, that is really, really hard for these large language models, like all of them across the board. Industry wide, this has been a hard problem for large language models, is positional information of of how things are relative to each other within an image. All right. And it's fun. Like doing something with Wordle would allow me to do something fun and interesting. It gave me a reason. Like I have to do this Wordle every day. It's for work, you guys.
Yeah.
And it helps you guys learn, right? Because it's fun and interesting. And so always choose a fun problem when you can, because it sticks in people's minds. All right. So let's talk about like the limitations though. So this is taken right from OpenAI's webpage. And so one of the things, I'm going to call your attention to the bold here. One of the things that is super important is that like spatial reasoning, again, as I said, is a known hard problem with these models. And when I created this, I actually created this November 2023 is when I was doing this work. So I submitted it to a conference in December 2023. So this is something that I was using GPT-V, the Vision Preview at the time, which had just been announced by OpenAI on at their Dev Day that year, which was on November 6th. So anyway, this is a known thing that this precise spatial location within it is hard. So just keep that in mind as we're thinking through this. All right, so let's try. Here's my very first thing that I tried, you guys. I started with the hello world, and any hello world with a vision model, with an image understanding model like GPT-V or GPT-4o can do this as well. The Florence model can do this. There's several other image understanding models. This is the hello world of image understanding is describe this image, or what is this? So I did do an image like that. I think I said describe this image. And I put in an image like that. And what that allowed me to do is just understand, does the model have some understanding of Wordle in its training data? If I just give it a screenshot of a Wordle image, and I actually cropped it, I actually had a landscape image, but I cropped it so it would fit on the slide. If it has this information, like, does it know the rules of the game? Like, what does it know? And this is what came out. So what this told me is that, yes, the model did have knowledge of the game of Wordle, because it said, this is a screenshot of a Wordle game. I identified the game. It knew the rules of the game here. So it gave me kind of a quick description here. And then it actually kind of walked through, and I highlighted the things in here that are wrong. So you can see it was not able to just in one perfect prompt, well, one very simple prompt to describe this image, it wasn't able to get it all right. So none of these letters are in the correct spot. Was incorrect for rates, because you can see it actually, there was a green E, which gives us a lot of information. It said L is in the word, but not in the right spot, but that's wrong. It was actually the I that's that way. And then so it kind of superimposed, it transposed the L and the I here. It thinks O is green. It probably was getting the green from below, because you see O is right above a green here. And then N, it got wrong. So you can see this is not perfect. We got our work cut out for us, guys. All right. So what did I do? I started by looking at this one really cool research paper that was created by Microsoft Research. They did a look at kind of a deep dive exploration. I had actually done one as well. And I wanted to see the one that MSR had done on GPT-V and like what its capabilities were. And so one of the things I wanted to see is like how well will various things work. And one example actually was really interesting to me. I'm going to jump out and just pull up the paper real quick so you can see it. Okay, so this is the paper. Let me zoom in a little bit if you guys can read it a little better. There we go. Okay, so this seemed similar in hardness to what I was trying to do. This is an example that they gave. What is the read of the speedometer, essentially? And you can see it is totally getting it wrong when you ask zero shot, which means apropos of nothing. We're not giving any examples. We just ask and we want a response, and it cannot do that. The other thing you can do is something called chain of thought reasoning, which you've probably talked about on the show before, Seth, but that's the idea of thinking step by step, because when you move through and kind of are telling you what your assumptions are, it can use that information to make better judgments. And so right here, let's think step by step. So, okay, it's kind of giving you a little bit more information here. It's still getting it wrong, though, in this thing. And then here, we're actually doing two different things together. Or I'm sorry, we're doing a different thing. We're going to try, let's give it text instructions. So instead of just saying, what's the read on the speedometer, we're telling it how to read the speedometer. So to read it, observe the needle on the outer edge, which points to your current speed, represented in miles per hour. It actually has kilometers per hour in the inner thing as well. but it's asking for the miles per hour, and it says yellow is the color of the needle. So we're giving it that information, and it still is like, nope, not getting it right. Okay. So then combining those two methods, the think step by step for some of that chain of thought reasoning capabilities, and with text instructions, putting those together, you can see it gets a little closer. It is thinking step by step here, and it gets it all the way to the end. It still does not get it. All right. And then what we're actually able to do here to solve it is using a technique called few shot. So what that means is giving examples in this domain. So now when we're saying, what is the read of the speedometer here? It gives the right answer back and then gives another one and then asks for the answer to that one. And note that we're still not able to do it here. And then again, another example that's still not able to get it. And then we tried again with multiple two shots. So we're using two examples now. And what I like about how these two examples were chosen is note that the needle points one way in one and then the other way in the other. So that can help tell it that it like, it's not that it's actually, just in case it was kind of always using one area, it kind of recognized that it's the pointy end, not the rounded end, that matters. So that will give you more information. So choosing your examples smartly is good. And then see, yay, it actually finally gets it at this point. All right. So we can do this. This is doable. So that gave me hope. So let's jump back to my thing right here. So I use this example, and then the big insight right here is use few shot examples, right? And so this is something I've talked about in a lot of my talks in the past, like few shot reasoning is very helpful. So I did that. I put in a couple of different examples. I've been screenshotting my Wordle boards every single day, and those are all in the GitHub repo that I will share with you at the end of this talk, where I have all of this posted. Yeah. So you guys can go check it out. And I actually have all of it. It's actually a horrible code if you're one of the people who likes like code deleting, because this was the spirit of a journey talk, I left in like all of my old code examples. Like I tried this, then this, then this, then this. So there's all of these different old code in there, but you can see the whole thought process as I went through. And so you can look here. I did few shot on this one. I actually used 2 as my end, just because I think probably because I saw it in the paper too, and it just 2 was stuck in my head. But I gave 2 different examples here. And then notice on the very first try, I got a few colors wrong, a few positions wrong. The character extraction happened to be correct that time, but with generative AI, remember, you can never run it once and then extract patterns from that. It's a different output every time, non-deterministic. So you must run it lots and lots of times and then kind of see over time, like, does it work or not? And so color extraction, or character extraction is actually not correct over time. And I can show you the code on this super quick. I'm worried about running out of time here. But here's kind of what the code looks like here. Let me also try to zoom in a little. So this is like what I was doing here. And the prompt that I'm using is focus on the letters and colored boxes in the center of the image and list all letters in green box and what column they are within their row. List what letters are in yellow boxes and their position. I think I said position. So I said column here. I said position here just to change up the wording, and list which letters are in dark gray boxes. And we don't care like where they are in the row because we just know it's not in there. So where it is doesn't actually matter for gray. All right. This is just how you base encode an image. Here are my few shot examples. These are in the GitHub repo, so you can go look at them later if you'd like. And then just kind of the content headers. And then at this time, so when I was creating this, like, it had just been released, so we didn't have a nice clean SDK. So that's why you see this ugly code where I am literally hitting the REST endpoint and like putting this all together myself. What I need to do is go back and like clean up this code, refactor it, because now we have lovely SDKs to do a lot of this and make this code a lot neater. But at the time we did not. And
There's
so
no shame here. We're not going to shame you, Jennifer. This is great. And you take as long as you want.
No. I'm calling out best practices. I'm calling out best practices as I go along. But definitely this code, I feel shame on it. But anyway, here we go. So identify the letters, guess what color it is. So a very basic system prompt that you might see. I pass in the text here. I kind of have a little thing. And then here's my few shot examples where I have the assistant, and then I give the right answer. So here's what I want. In this puzzle, this looks like this. In this puzzle, this, and here's another example of what it got wrong. And then here's the actual one at the end. And now we're kind of doing our little ... for the completions API to see if we can get the right answer. Okay. So let's jump back to this. took a quick look at one of those earlies of code. And then you can see that, yes, it does not always extract the characters, as I said earlier. So this one missed the Y and didn't get the Y right. And so what I realized is that no, it really couldn't do, of the 3 things we need to find out, you guys, the position, the actual characters or OCR, whatever you want to think about it, and the colors, I was getting none of them consistently right. So taking a step back, I started to think about characters first. And so let's just think about how the model represents language, right? So we as humans are very familiar with the concept of words, and we're familiar with characters, but the model actually thinks in tokens, right? So let me just give you an example of what those look like for the 3 of these. A word might be standoffish, and what that means, if English is not your native language or you're just not familiar with that word, it's like, it means kind of aloof or stuck up a little standoffish. You don't always engage. And so if we break this into characters, obviously each letter would break into its own character. And when we tokenize this, it actually forms 3 distinct tokens, because ish is kind of a suffix in the English language that means like having characteristics like this adjective. And then standoff is like you're aloof, you're standing off, but there's kind of these 2 separate concepts of stand and off that are coming together, which is why I chose this word. So standoffish actually tokenizes into 3 different tokens. All right. And we can actually, if you want to see how your language tokenizes, there is a tokenizer on the OpenAI website here. And you can actually enter things in here yourself and see how they tokenize. And there's an example here. I'm going to skip it for now, just because of time. But like, I'll just try Jennifer's queen-like behavior. Sorry, I was trying to do the British you there. All right, and you see how this tokenizes? So in the English language, apostrophe S is the possessive, but that kind of has its own little concept of being being possessive of Jennifer's, like belonging to Jennifer. And then queen-like, kind of like ish, like is another suffix that means has behavior like. So I could change this to CEO-like or childlike or whatever. And those 2 would tokenize separately. And then behavior is all by itself. Okay, so that kind of makes sense that it tokenizes into these distinct concepts. And it could be sections of characters, or it could be a whole word by itself. Okay, so that's what tokenizing is. So that was our quick sidebar on tokenization. So I started thinking about that and thinking, man, characters aren't extracting well because it really doesn't have a concept of characters. So I started doing some, all right, these are what I already showed you online. This is the example that's on the OpenAI website. You can go and try that yourself if you'd like. Here's the demo I did, so I'm going to skip over those. So I was thinking about like representation of characters, and I was doing search and research on this, and I came across a blog post by Andrew Main. And so Andrew actually used to do, evangelism, kind of what I did for Microsoft. Andrew did for OpenAI for a while, and we actually connected and we're working together on some stuff at Build, not this year, but last year, I think it was. And Andrew had created, I found this, I did not even realize this was out there, but he had written a blog post on playing Wordle. This was before the vision model. So this was just how to do it in straight text. And there's some good stuff in here, but the big insight I picked out of this is if you put square brackets around the characters, that helps the model understand to extract the character as its own little token. And I was like, let me try that. Yes. So what I did is, this is kind of the same. So this is what my system prompt looked like, and you can kind of read that at your leisure. This is what you can do, model. Here is a new image. Because I was doing few shot, I wanted to start my user prompt with, here is a new image. So it didn't try to take there's a yellow L from like one of the previous examples. So I kind of started it with, this is a new image to hopefully clear out the memory somewhat. And then say, focus on this, find, and then kind of what you already saw there. And now in my few shot examples, I put these square brackets around it. Okay. So this was kind of the insight that I got from Andrew's blog post. So I added that in. And then boom, it worked, you guys. Of course, I tested it lots of times, as I said before, but running it lots and lots and lots of times, it was correctly extracting the letter. So check, we got one of them. The OCR, the character extraction, is working, but we're still not getting the colors right, and we're still not getting the positions of where they are in the word right. Okay, here's another example, same thing. Letters are right, characters aren't right. All right, so in this one, the positions happen to be right, but again, it was just happenstance because, as I said, I ran it lots of times and the positions weren't consistently right. Okay, so I started thinking some more, you guys, and here are kind of the next kind of set of insights. So one thing I thought about was chaining, okay? So it is much, much, much harder to have the model do things in one single pass and to do a lot of complicated things in one single pass. And so that's why you see a lot of chaining and why great orchestration engines like the semantic kernel and LangChain have popped up that help you do this chaining really well. So you can do like, have the model do one thing and then another thing and another thing. So smaller, more focused prompts can sometimes work better than one bigger, huge prompt, and it allows it to do, multiple passes. So one insight was like, okay, if I can get characters consistently, maybe I should do one call to get the characters and then make a separate call to get colors. So we're going to try that next. And then the other thing I had is, Seth, I'm sure you're super familiar with this, is that in machine learning, like before generative AI, like a long time ago when Seth and I were met, 10, 15 years ago on the speaking circuit, one of the things that we both knew and talked about at that time is that open-ended questions are actually much harder in machine learning than classification, than choosing between multiple known buckets. So instead of this was one of those insights that came to me at like 2 a.m. or something. And I'm like, Jennifer, you're so stupid. Why didn't you think of this? But instead of asking what color is the box behind the X character with a whole rainbow of possibilities to choose from, I asked, okay, is the color in the box behind this character closer to green, yellow, or gray? Because it's going to be one of the three, right? So that's what I ended up doing. And that was another kind of insight. So here's the pseudocode that I used for this. We have this color wrapper. First, I make a call to the model to get the characters. I parse out so in the response, you have to kind of parse out the actual response. That's what I'm doing here of like, what's the character test? And then I had to parse out the characters from the brackets because they were all in square brackets now because of what we did before. So this gives me just a list of characters. And then what I did here is for each letter, I called, all right, can you find in the image, find this character and tell me what color is behind it? So I tried that, you guys, and did not work. It was not very good. Boom. Yeah. So here's one example I had, and you can see it got 3 out of the 5 right, which was not good enough. So it kind of does that, and it's just not kind of being able to focus in the right area. And let me also tell you one other thing, guys. Remember that the model I'm using here is the vision preview. So this was the 1106 vision preview. So way back from, November 2023 at this point. So a newer model may do better on these things, just to say that. Okay, so here's what I did. I started thinking about, okay, I needed to focus on a certain section of the image. It's almost like the kind of image detection within a larger image. I need to focus in on something. And it made me think of this other concept from the same MSR paper that I referenced earlier. So if you look at this example, here's what their prompt looked like. Please follow these instructions. Tell me the size of the input image. It actually can't do that because it's like metadata on the image and it can't read metadata. It only sees the image itself. Localize each person using a bounding box, recognize each person, and then generate a detailed caption. So what was exciting to me about this is, it is doing recognition in a section. It's doing localization within the image and able to do something with that. So I started thinking more about this and looking at this, and I don't actually want to do captioning at all. I don't care about that, but I did want to be able to focus on a section like that. And so one of the things that actually helped from this is that it said localize each person in the image. So I changed my prompt to look more like that. So this is the system prompt is the same, I think, or similar, but here's the new thing. Please follow the instructions. Focus on the letters in colored boxes. Localize each colored box containing a letter using a bounding box. I said using bounding box just to kind of imitate their wording. Identify each colored box as green, yellow, or dark gray. You guys, I think that was the key. Do you remember what my system prompt looked like before, or user prompt? It was find all the green things. and recognize them, find all the yellow things and did it, find all that. Like I was going by color in order. This actually allows the model, I think this is my hypothesis. I think this allowed the model to actually parse the image like in order and then identify like the color as part of its natural flow. But since it was kind of parsing more in order, it's able to get the positions now.
Right.
Okay. So that's what the big insight was. And then again, it's so clear. Like after you've done it, you're like, oh, duh. Like that makes so much more sense. Because once it started working, I was like, oh, that's probably what was happening. So the logic made sense. So again, using the prompts that you just saw here, and just zero shot was not good enough. I tried it just zero shot first.
Yeah.
Did not work. Added in the few shot and character extraction. Yes. And positioning, understanding. Yes. So we are there. 2 of the 3, my friends, are done, but we still need color. The color was not working. So what I did was, this is kind of where it would go into, if this was a movie, we would go into a montage of me going like this for a long time and thinking and because it's really boring. So we would like montage at that point because, you know, there's nothing exciting happening. But like what I did was a lot of experiments about like, how is the model representing color? Is it RGB? Is it hex values? Like you can see kind of the different ways that color can be represented. There's a lot of them. So I started just messing around with the model, trying to figure out. And one of the things I did was actually ask ChatGPT, because it's using, you know, the same model under the covers, like, hey, do you know what this color is and stuff, just to know that, you know, the model itself, that same kind of base model, understands what these colors are. And I know it does understand color, you guys, because I've done this in many other things that it can recognize color. But again, for the montage, yes, all of these things exist. It's able to recognize them. So I did a bunch of experimentation here. But the short version is that I was not able to get the model to do localized color effectively. And I think that was asking it an awful lot to do in one pass, to nail all 3 of those in one pass. But how can we test this? So we can actually extrapolate, kind of tease out these confounding variables by doing color extraction tests without the spatial aspect. So the way I decided to do this and isolate my variables a little and just focus on the color variable is, why didn't I have code do the chunking instead of relying? It's like, I know the model can do the positional part, like, because we just saw it in that previous test. So I'm like, let's have code chunk it up, because we know that the Wordle board is always, it's always 5 letters. So it's always a 5 by 6 matrix. So I just wrote some Python to do the chunking in code and then have it send each of those tiles to the model. So I did that and just sent the board like this and had it do it. And you can see right there that it is able to get both the characters and the color correct consistently. Boom. So we can get 2 of the 3 consistently at any kind of time is what this test tells us, right? So we could get color and character together, and we can get character and position together. So that does work. So it just may be that the model is not able to process all 3 of them in a single pass, which is fine, because you can do multiple passes if you need. But this at least proved to me that the model can recognize color, and it was able, running it lots and lots of times consistently, it was able to do that. Okay, so then we've nailed the 3 different aspects here. So the next thing is how to choose which word to guess next. And there's 2 different ways to do this. You can ask the model to do it, and the model can actually do some cool stuff there, or you can use code. And so I actually chose to use code, and here is why. I actually wanted to create a teachable moment of sorts, because one of the things that you and I have to do, Seth, is we have to defend our positions either to customers or to our vice presidents that we work for, or whatever important people. You have to say, like, here's why I made this choice, and here's why it's the right choice. And when you think about it, there is a lot of things that already exist that you can do like really, really easily with just code. So think just code, right?
Yes.
So there should be a little pen sitting on your shoulder when it is just code that tells you, like, dude, this is just code. Like, stop. And so one of the things, I think one really great example is math, arithmetic, right? So large language models are really not good inherently at math, at doing like simple calculations. And when you think about it, like on CPU, we can do regular calculations, no problem, like at a fraction of the cost. Like we think about a large language model that is running over multiple GPUs. It is very expensive, a lot of, like, if you think about the sustainability aspect, like I was the principal engineer on AI, like is just stupid easy to have a CPU do. Like, that's a really hard choice to defend to a VP. So the point I want to make here is that there are extensibility points built into this model for a reason. So whenever you're like, hey, I can do this just with code, like, although it may be a really fun research thing to have the model try to do it, and believe me, I did try having the model doing the other thing as well, because that's just fun. But at the end of the day, you really should just use code. All right. So have a little Ken sitting on your shoulder that does this little dance. If you can easily or cheaply do it with code, use a plugin or a skill or an action or whatever we're calling it nowadays, since we like to change the name. All right. So you leverage that extensibility point to combat the model's weaknesses, like calculations of arithmetic, to augment the model's value, or when you already have existing code that just does something, like you have this built into, like, it's legacy code, we have a little chunk of code that does this already, just call it, expose it on a res endpoint securely, and then call it from your code, and then just suck that in, and the model can use that data. Okay. So it's also a lot cheaper than having a large language model do it a lot of times. So to practice what I'm preaching, I actually went and there's a million Wordle solvers online. I actually looked at a whole bunch of them, and there was one that had an algorithm that I really liked. So I looked at a whole bunch, and then I'm like, I think I like this algorithm the best. And then I went back to try to find it, and I could not find that webpage again. So what I did is I did write the code myself. So any yuckiness in the code for doing that solver is my fault, but I can't take credit for the algorithm because I think I did find it or see it online somewhere. And so I was kind of just writing it from how I remembered it online, but I can't take full credit for the algorithm because I think I saw it somewhere. And then for the Wordle list of known words in Wordle, there was someone here who was put it under the right license. So thank you, Tab Adkins, whoever you are. I did find it on his or her GitHub, and I leveraged that one. And then the other thing to note is that there aren't support for functions. So this extensibility point that I'm telling you to use, the vision preview model did not support that. So that's another thing that if I go back and rewrite this, I probably will go back and rewrite this with 4.0, because it is a cheaper model and a faster model and a much better model to use with image for image understanding than the older one. And it does support functions. So my goal is to go back and rewrite this, and I will add function support and then use 4.0, the Omni model, as it is a better one here. And it worked, you guys. So you can see here that the output here was that. Here's another example. I wanted to test multiple yellows in one spot because that's actually like a hard use case for the way the code worked. And that worked as well. So let us finish, my friends. We're over time.
We have time. If you have time, I have time.
I want to do this, man.
Let's do it.
All right. So here is the Wordle for today. I don't know what you usually do, Seth, but I always start with rates. So I'm going to go ahead and start with rates here, and then we're going to get going. So I'm going to just type in rates is like my go-to word. I actually have a strategy that I always do. Oh no. Okay. This is actually going to be super hard because when those are all, this is not a good word today. When all of those are gray, it's going to take forever, right? So what I'm going to do though, is I'm going to screenshot this thing. So I'm going to hit, what is it? Windows Shift S does the snippy tool. And so I'm going to do a little snip around here.
I thought I was the snippy tool.
Oh, you are the snippy tool too. I get it now. Sorry.
Yeah.
Wah, wah. Thank you, Seth. Okay, so now I'm going to jump over here to my code. So this is the code. I threw it in a Gradio UI because I am horrible at UI. And so Gradio is my wonderful friend that is a Python UI library. And so this allows you to upload an image, which is great. I have a whole bunch of sample images in the repo that you can use if you want. And then this is the pasted in. And so it pastes it in very nicely. And now it's running. This is going to take a while to run, again, just because of how bad my first guess was for this particular word. Usually rates does really well. But since it's all gray, there are so many options that are going to come back on this because like the lack of those letters is not going to.
For Wordle, do you get to as a student, I never play Wordle. So do you get to input the first line of text or?
No. So what I have to do now is I know that none of these letters are in the puzzle. So I need to guess another word. So what I usually, my normal strategy before I wrote this to help me solve the puzzle, my normal strategy was to do rates and then to do either phony or climb next because none of the letters intersect. Oh, there we go. Okay, so either of those would work. So if you look at this, there's a huge long list of options just because it's so big. But as you can see, there's a lot of different options here. So oh, phony is in here. So I'm just gonna do phony next, I think, because that's my go-to and it is in this list. So I'm gonna go back to here. No, sorry, not you. I need to go back to my actual Wordle puzzle, which is here.
That one.
Put it in this one. Yeah, thank you. And so since phony was one of the options, I'm going to go with my standby phony because that I always do I like phony or climb, and there were some answers. Okay, so phony actually got us some love. Good. So what this means, Seth, is that there is no P, H, or N in here. There is an O, but it is not in the third position. It is somewhere else. And then there is a Y, and the Y is in the last position.
Oh,
so
okay.
again, I snipped that, and we're going to go back here to the Wordle or to the Gradio. And I'm going to now repaste this here, and that the event triggers the model call to happen again. Oh, shoot this so that you guys can actually see what's happening. So here's what's actually happening. Oh no, the connection was forcibly closed.
Was that on the previous one? It's still going.
We might. I don't know.
It's still going. I think the cool thing is that
good
because the model.
I'm worried about like quota issues. Boom. Boom. Boom.
Sorry, you're breaking up.
So you can see these are all registering as dark gray. Yeah, it is working, and it is correctly identifying that this is, so see how it's processing each of these.
Yes.
I did the chunking of those two where we're doing the positional stuff. It is getting all of the characters right, all in the right position, and then you can see it's identifying the colors of each properly as well. So in order, we're seeing this dark gray is S, and then next is the P is coming back dark gray, the H is coming back dark gray, O is yellow. Yes, so it got that one right. That's a harder one. And then the dark gray, and then we should get next Y is green. Fingers crossed. Woohoo! All right, we did. And then now, given that information, we make a final call to that, given all this information, and our Wordle solver should give us the things, and you can see that, yay, we did get some good valid options here. Let me minimize this for 1 second. All right, so what should we pick? I kind of like Godly. Godly is like 5 unique characters. What do you think? Do you have a preference?
What? So is O have to be in the next word too?
Yeah. So we know O is in here. It doesn't have to be unless you play on hard mode. There's like a hard mode where everything that you get, you have to keep using in there. But Godly might be right because I like Godly because it gives us 3. So see that there's a bunch of G's. So that will tell us if there's a G in the puzzle, like even if it's Goldie or Godly or Gobby or whatever. And then there's some D's here as well. See Dodgy and Dolly and Dodie and Dowley or whatever that word is. So like that will give us a lot of information on like these distinct letters. So I like Godly. I'm going to try Godly. Let's do Godly. Okay. So I'm going to go back to here. We're going to try Godly, Godly, which will give us information on all 5 that look. So fingers crossed. Oh, it's not right. Okay. But this gives us a lot of good information. So the D is there and not in the right place. So the only place left is here. So the D has to go here. So it's D-O something L-Y. So we could probably guess from the previous list, but let's do it the right way.
So are you trying to just guess what the word is in the least amount of tries? Is that what Wordle is?
Yes.
Okay.
Yeah, that is the goal of Wordle. That's what 5-letter word is in the smallest number of things that you have. So let's go back and paste that in.
So that's why, as you're typing this in, that's why the first one took so
Okay.
long, because you basically could not use any of those letters.
Yes. You are exactly right, Seth. That is why, I'm sorry, you're breaking up for me too. But that is exactly why the first one took so long, is because there were so many options at that point, but now we're really reducing them. And now another thing that I could do is I go through a process over and over every single time. So you can see I'm resending everything each time. So we go back and we reprocess rates, and we reprocess every single time. So another option here is to just do like the latest and just remember all of the characters. That would be another good optimization to do in this code. But yeah, so you see it's coming back correctly. Let me make this a little sideways so you can see what's coming through. So we know T is dark gray, not in the puzzle. We know E and S are not in the puzzle because they're dark gray. P is not in the puzzle. H is not. O is, but it's in the right place. So we found out that the correct place on the next round, we found that it was O, or when in the second position. And then we will find out here. It's probably, what did you say?
Dolly? Dolly?
Dolly sounds like a good guess to me. I can't think of it. I think there was one other, like Dolly or something, or like Dowly. Is that a word? Maybe not.
I don't know.
But Dolly is like more common. I would probably guess Dolly first too. Yay. Okay, cool. So now it finished. And if we look here are, doily. Doily is also a word. I like Dolly. You chose Dolly. Let's try Dolly. So if we go here back to this guy and put it in Dolly with Seth's choice. Boom. Yes! All right, awesome. So, and now it's going to make me do an account. I did it there. Okay, so Dolly was in fact, and I could actually copy and paste and put that in, and I actually have a little like, congratulations, you solved the puzzle, will come out at the last thing. But since we are over time, let's stop there. But yay, we did it. So guys, fingers crossed, it worked. We did solve the puzzle. So some last quick things to share with you. My code repo, if you want to go through and see the whole journey and all the different prompt iterations as I went through, is right there. Make sure to use the best practices though that are not in my code yet. Use a framework, use training, use functions or plugins or those extensibility points that did not exist when I was doing this with the early version of GPT-V. And then here's a quick look at all the resources, the vision guide, that paper from MSR that I was using, the OpenAI documentation, my repo. And then if you didn't take anything away from this talk, but like Wordle looks kind of fun, there's the link to play Wordle as well. Thank you guys so much. I'm happy to take any questions if there are some.
This has been amazing. I haven't seen any questions, but get some questions in if you have any. Hey, thank you for staying a little bit later. This was great. I love for me, the process I think is important. And the other thing that I think you said that is just absolutely spot on is stop using LLMs to do stuff that you already know how to do.
Yes. Remember, I'm just Ken, and then just stop and just write. Right. It's just code, guys. It's just code. Call code. Yep. I
had a professor in my advanced algorithms class a long time ago be like, stop using a shotgun to kill a fly.
Exactly. So, that's a great analogy.
Awesome, Jennifer. Well, thank you so much, my friend. We'll see you next time.
Great. Take care. Bye, guys.
How about them apples? She's the best. We always love having Jennifer on because she knows so much. So I need to actually do the walk-up music here on the short version. Next time on the AI show, we are going to be finishing our Neuer.ai app, our marketing AI specialist, who is going to help us promote the AI show for those that don't know. By the way, we have a good amount of folks on, I think a lot on Twitter. We have some on the YouTube. So if you go to AI show, if you go to youtube.com at the AI show live, you can like and subscribe there. We want to make sure that we can get some of the shows to you. So we're going to try something a little bit different starting next. By the way, the way we work in cycles is Our next cycle starts in July. We want to do more of what you want, and so maybe we'll put something up so you can tell us what you want to see, what you want to learn about, and we'll make sure to get it up there. As always, I know you can do a ton of things with your time. We appreciate you coming. Thank you so much for watching. And if you have any questions, comments, complaints, make sure to reach out to us, and we'll address them. Thank you so much for watching, and hopefully we'll see you next time on this, the AI Show.